Alright, so this video is about finding the limit algebraically, and we're going to find it algebraically because in this case, using L'Hopital's rule is probably not the most efficient way to find the limit. For example, as x approaches infinity in the numerator, you get infinity. It grows forever. As x approaches infinity in the denominator, it's also going to grow forever. So in this case, you think, well, I can use L'Hopital's rule. And if you try it gets kind of messy because now it will be the limit as x approaches infinity. This is a radical, so it's going to wind up being, the root of that would be 1/2 9x to the 6th, subtract x to the negative 1/2 times 54x to the 5th, subtract 1, all over 3x squared, and that's a 54 there. Anyway, so this is kind of messy. If you try to simplify that even further, you get the limit as x approaches infinity of 1 over 2 times 54x to the 5th, subtract 1, over the square root of 9x to the 6th, subtract x, times 3x squared. If we test that, that limit is also infinity over infinity, which means we can try L'Hopital's rule again. And it's going to go on and on and on and on and on, and it's not going to get any less complicated. So because of that, we should have other ways, other than just depending on the calculator. Because yes, you can plug it in the calculator and easily find the limit. So we can talk about using algebra to do it. And this is what I would do. With algebra, I can essentially divide the numerator and the denominator by the term of the highest degree. In this case, it's x to the 3rd power. So if I divided each part by it, I'll get the limit as x approaches infinity of the square root of 9x to the 6th, subtract x, over x cubed, divided by x cubed over x cubed, subtract 1 over x cubed. Alright, so the denominator simplifies pretty easily, giving you the limit as x approaches infinity of, the denominator becomes 1 subtract 1 over x to the 3rd. The numerator, though, because you got a radical there, you want to rewrite it so that that square root, that x to the 3rd can now go into the radical. So if you're going to make x to the 3rd go into the radical, it has to become something else. Because square root of 9x to the 6th, subtract x. In order for x to the 3rd to be divided into that radical, it's got to be the square root of x to the 6th. Why? Well, the square root of x to the 6th is x to the 3rd. So it's essentially the same thing. It's just a cosmetic adjustment. So with that being said, there's a problem in algebra. There's a theory in algebra that allows us to say that if we have a square root divided by the same square root, then we can divide the numbers underneath those radicals. So now that gives us a limit as x approaches infinity of the square root of 9x to the 6th divided by x to the 6th, subtract x divided by x to the 6th. And that's all over 1 subtract 1 over x to the 3rd. Alright, so from there, I can reduce this, like x to the 6 over x to the 6 cancels, leave you just 9, and x over x to the 6th gives you 1 over x to the 5th. So it's now the limit as x approaches infinity of the square root of 9 subtract 1 over x to the 5th divided by 1 subtract 1 over x to the 3rd. Now great, and when we find the limit here, we can now take the limit as x approaches infinity of the numerator and the denominator. So we got a limit of the numerator and the limit of the denominator. Now we should have had a discussion so far to talk about as x gets infinitely large in this fraction, this fraction gets smaller and smaller, closer and closer to 0. So as x goes to infinity, this approaches 0. Same case as this fraction. When x gets infinitely large, this fraction part goes to 0. So it basically leaves you with a limit as x approaches infinity of the square root of 9 divided by 1, which is the limit as x approaches infinity of 3. The limit of any constant is the constant, so the limit has to be 3. Now we could have found that with the calculator. This is the algebra of it all. So we can actually find the limit of that by dividing all the terms on the bottom and all the terms in the numerator by the highest degree, the term of the highest degree in either part, numerator or the denominator. And that's how we can solve that algebraically. Now there's an example in the textbook in section 4.4. I think example 4 explains this again. So if you need a second note or another way or maybe more explanation, you can start by studying that. That's all I have on that topic. Moving on. Well, that's all I have. Good luck.